Yeah, welcome everybody. So my name is Herman. I hope you can hear me. So I'm from FRISS. So FRISS is a Dutch company. We're based in the Amsterdam region, and actually we're based in Utrecht. It's a famous tower. I'm a team leader there. So that's me. Aaron is my colleague over there. Sebastian, who's doing a lot of network stuff, and John Liuzzi, and he is our visualization expert, and he does a lot of really cool stuff building charts. We are a little analytics team. We also have two other people working on the site. So these are more hardcore developers or system administrators who help us to set up our stuff, and we do a lot of stuff with Shiny. So Shiny is our presentation layer. It's our sort of tool to build really cool analytics, but we want other people to show our analytics and use our analytics and give insight into the data that our company generates. So FRISS is a system which can be used by insurance companies. So we have a 100% focus on actual working on risk assessment, on detecting fraud and ensuring compliance. And we built a scoring system, which is called the FRISS score, which is a quantitative assessment of risk of fraud on either a person, a case, an object, or a whole company. Doing this, we work in regions like risk assessment and underwriting, which is at the moment where you file for an insurance. We do stuff with fraud detection on claims. So you say, I've got a claim, and then it's the insurance company, they have to know if they want to pay that claim or should they investigate that claim. And we help to do an optimization of the whole portfolio, and R plays a role in that. So how can R help us to detect risk and to eliminate fraud, to secure compliance? So we do a lot of stuff like text mining, device screening, BOR screening, social network analysis, profiling, image screening. So for instance, you hit your car, you make a picture of it, you send it and say, look, I crashed my car. But that could be a tampered photograph, so how do you know this photograph is actually real? So stuff like that. So we do a lot of things like this. And what actually happens is that we have a FRISS system, so it's quite a complicated system. And here is sort of where the data goes in. It can be a web request, could be some system at the insurance company, could be something else, finance system, call center. And they send in information into the system. The system uses a lot of data sources, so this is what FRISS actually specializes in. That's our main product. It's not analytics, but it's actually making all these connections to all these external databases based on some prior information that the user gives them. We enrich that data, and this goes into a whole pipeline of indicators, business rules, statistical models, stuff like that. Whatever comes out of that we analyze and we visualize that. And this is where R is being used for us also to do statistical models on the likelihood of fraud or to do network detection. So I come to that later. And because we generate a lot of data, people have a lot of questions on this data because you cannot see all that data. People want to see that because then they can actually comprehend what is actually going on. They also have a lot of ideas on what the data should look like, but these are hypotheses which either can be justified or they can be debunked by showing a visualization or a time series or stuff like that. So as a data analyst, where I traditionally come in is stuff like export models, which are knowledge rules which are based on prior information, like things that we knew to be true even before we had the data. So you could say this is domain knowledge that we know. Also, we do a lot of profiling, which means I know what normal behavior is, and I just want to know, are you not normal? So are you some kind of edge case that I need to look into? We also do a lot of predictive models, which means we use historical data to do supervised classification on historical data to model classes and to predict those classes and to say with what likelihood you belong to a specific class. And then very important thing in analytics is actually, in our analytics, is network-based analysis, or traditionally maybe called link analysis, social network analysis. And we use all that information to create this score. So we want to create the best risk score that insurance companies can actually do. So we are working now in a lot of different places around the globe, and we are the European market leader in doing fraud, and we are the globally, I think, #2 player doing this. And what tools do we actually use to do this? So obviously, as we're all here, R is one of those tools. That's not a surprise. But what else? What else is there that we use, or how do we actually use it? So what we do, of course, we start with R. Major point in this story is Shiny. So we all know Shiny, I guess, here. And Shiny serves to make a static thing which you can run in R interactive, and say, I can share this also with other people, and they can make decisions, say, maybe I want this data set, maybe I want to take that out, see what happens. So they can do exploratory things. We use Shiny Server, Docker, and Apache to host those applications. So if I have a dev server and it just sits there and says, look what I made, and then I can never share it, that's no good to anyone. So that's not going to last. So we have to deploy this somehow to get in that mess of packages and different releases. Docker is really nice. Also, Docker Swarm is something that we're working on. We're not actually doing it now. But in that way, you would have not a fixed number of machines which do fixed tasks, but I have a resource pool which I can use, and I can do all kinds of stuff with that. So Docker, I think, is going to be a major thing in the future. It is already a major thing, but also for the R community. We also do a lot of JavaScript. I will come back to that extensively. So this is a very nice language to extend. Actually, when you think about it, Shiny is doing a lot of JavaScript for you. You just don't know, you don't have to know what is actually going on there. Then we use a lot of external databases. We use Shiny modules. So this prevents you from getting spaghetti code with code that just balloons up. We use a lot of templates, so then you can do straight HTML, just use a little bit of R, but just use, say, 90% is HTML and 10% is only Shiny, which is completely reverse of what Shiny is actually doing, and HTML widgets. So I'll come back to that. What else do we use besides R? So we use MongoDB. We use the very nice Mongo Lite client that Jeroen owns, which is the second keynote speaker actually built. So very happy with that. We use Neo4j, which is an excellent graph database. We are looking at Elasticsearch to help us out. We definitely use a lot of SQL Server, and our hosting is going in Docker containers. So to paraphrase a speaker here, like Gabor, he said, everything that can be implemented in JavaScript one day will be implemented. This is actually a quote of somebody else. I didn't know who that was, but Gabor informed me that it was Mr. Atwood who actually said this, and I think it's true. Shiny is just creating a lot of JavaScript for you. You just don't have to know it. That's what they say. But if you do know it, that comes in handy. So if you know modern tools are built with these, modern websites, if you present something, it's very nicely presented on the web. What do you use? This is what's happening in your browser. One way or another, this is what is being rendered. Also use .NET or whatever. It just gets compiled to something like this, and then you use it. So if you know this stuff, that's pretty good. So now you got yourself sort of an ecosystem in which you say, oh, I got a lot of stuff from our studio, and you got the Hadleyverse, and you got a lot of cool books about that, but there's also a way bigger community which is doing JavaScript. So R is nice, but the rest of the world is really doing a lot of that stuff as well. So they're both great, and this is sort of my guide of how I did all these things. I'll come back to that later. And with those things, we built apps. We built a lot of Shiny apps, and they use a lot of, well, Shiny things. Like, it needs to look good, and that's what R does well, but JavaScript makes that what looks good interactive, which is really nice, because then I can do a lot of other cool stuff with that. So what can I do, and how should I do that? So somebody once said, and also in JavaScript, how do you make big code in JavaScript, or how do you make big projects using R? Well, the simple answer was, you don't. You make a lot of small programs, and they communicate together in a clever way. So that's sort of modularizing the code. And Shiny can do this now. The latest version of Shiny can help you out. So this prevents you from having a big app which blows up because you have so many lines you just don't know anymore what is going on. So there's an example of a dashboard application. Unfortunately, I couldn't show a live one because of the way the beamer was set up, so I was asked to do a PowerPoint presentation. But in the morning, we did an interactive version of this in the Advanced Shiny course. And this is actually something that you can just show. Here is the link. If you go to that link, it's hosted by our studio. So we set up some tutorials which I come to speak about. And you can just see this dashboard. You can play with it. We got a really nice tutorial which tells you how to build this. So what does this do with modules anyway? So what this has to do with modules is that this module, whatever it does, all these things are little modules. This whole thing, which is here, is another module. It's just doing these pie charts for me. The controller, which sits here, which can say, okay, apparently I have some things which we call red, and it's sort of the number of signals in our system for a given client, which are red. And red means you seriously have to look into this alert and investigate this. So you want that number to be low, but of course, they're there because the insurance companies, they have to look at something to see what's actually going on. Here's some timeline. So it doesn't matter what it is. The thing is, this dashboard looks like one application, but it actually isn't. It's an application which is about 30 modules, and they all work together in a nice way. Also, what we do is we do a lot of nice things with JavaScript. And if you know a little bit of JavaScript, and this is what I'm working towards, so a series of tutorials that you can all use, so it's all there for you to use, you can make it very easy on yourself to make your Shiny apps way more interactive than they are right now. So it gets even shinier. And it's just a matter of time before all these things are implemented by somebody like me or somebody else. But you can also do it yourself. You probably have some visualizations. So also from the music talk, I heard like, I want to build a widget. I already found something cool. I just need to get it to work. Help me out, get me that thing to work. So this is some visualization thing in which intro.js, you can make a nice interactive help over your application doing it. So if you go back to this thing, here you see a timeline. This actually got a mini version of that. So this is based on C3, which is a JavaScript counterpart of D3, which I come to speak about in a minute, which is huge. Like if you think Hadley Wickham is like famous, there is another guy, he's like super famous, and he builds all that stuff in D3. And what happens is, if you say, okay, all these things are interactive, so I can just, so at the time, I can have myself a brush here, and what I can use that brush to brush the timeline and to make myself a nice little filter. So what is actually going on? So I have my timeline here, and here I have a little brush, and this just comes standard with that library. If I brush it, I get events, but because Shiny is reactive, I can make a reactive data frame which just says, wait a minute, just tell me these bounds. Here, when did it start? When did it end? Use that to make something reactive into a data frame, and that reactive data frame is inserted in all these modules. And these modules, they just compute stuff. It's just Shiny app on their own. It can be anything you want. So we use different things to make different pages on our visualizations. And in our dashboard application, which is quite big, but if you see the code, this actually looks quite simple to do, because it doesn't turn into spaghetti, because this has nothing to do with that. The only thing that it has in common is that they both listen to this. So if I click on this or that, and Shiny takes care of all these things like, oh, what the hell should happen when I change this? Well, it knows what to do. So that's a very nice, oh, this looks awful, resolution-wise. But another thing that you can do, so this is why I don't want to do PDFs, this is a network viewer that we built, and it uses Neo4j to render that, to create the network. So Neo4j is doing the heavy lifting, but as always in R, there's a ton of connectors and cool libraries which help you out to see what's going on there. And so we have this, we use FRISS.js, which is another cool library to do rendering of the visualization. So it uses the force layout that a gentleman before used to find the God particle. And we have some interesting timelines, and you guessed it, these are all modules. This is not one piece of code, it's little pieces of code. But when I click this guy, it's a timeline, I want to know where on the network does this actually have any effect on. So if I click on a case, I can have the network automatically zoom into the right position to do that. So these modules, again, they listen to each other, and you can set up some really cool interactive stuff. It's really a shame I could not show it to you now, but it works really well, it looks amazing, people really like it. So if you want to get more popular in R, if you use tools like that, I want to do that, make yourself more popular, because I did econometrics as a study, if I talk about p-values, nobody cares. If I talk about moving balls and animations, everybody loves me. So this is really great, because making things move is a lot easier than doing p-values, at least for me. So what do? You find cool stuff first, if you don't know what you want to build and what you're going to do. So there's a ton of cool stuff here. I don't have the time to go into it, but this is, for instance, the library, which already exists. It's all JavaScript. So JavaScript makes it really interactive, which is really nice. Our studio is working towards this with ggplot, but they're not there yet. But it's really nice, and you can do all kinds of things. I really recommend you do this. It's FRISS network, it's really nice. Also D3, this is what I was talking about. It's got a ton of things. You can create HTML widgets doing this. Really an amazing number of packages. Here's our favorite dude ever, Hadley Wickham. He makes brilliant things in R. Here's Mike Bostock. He makes brilliant things in JavaScript. If you just look at the numbers, like, that's pretty small, right? 2K stars, there's 54,000 people who actually like that. I'm not saying it's better, it's just different. It's interactive stuff. So what did we do? This is a bit difficult to learn, or at least it's challenging. So with our studio in our company, we said, okay, maybe we should have a really nice series of tutorials. That was our part of the invitation here. So I sent that out, it already exists. And in these things, you can look at Shiny, our studio, at tutorial, and you can find all those things. There you will learn how to make the dashboard, how to make it interactive, how to do all these things, hook it up. It tells you how to do the communication from R to the browser, from the browser back, how Bootstrap works, how all these things come into play. It teaches you a lot of links, a lot of stuff. Tutorial is over here. So that will be made available to you. So if you go to it right now, you can just download it and use it. And from my colleagues in the Netherlands, I want to thank you, and I hope you really enjoy JavaScript, because R, Shiny, and JavaScript is awesome together, and you can make really cool stuff with this. So thank you for listening to me, and that was it. Thank you.
Questions?
Yes?
You said you model social networks. What kind of information is that? Is that Facebook data? Or
No, it's personal data, so it's from the insurance company. So if I know your name, if I know where you live, if I know what accident you were in, you're also on claims. So people, when you file a claim, you say, okay, that's registered by the insurance company. That automatically implies persons are related to a case. That case, that makes them, then we look for relationships which are implied. Everybody who is at the same claim, either me, a counterparty, a third party, they're connected. They own vehicles. That vehicle has a license plate, stuff like that, a VIN number. So that's how naturally everything lines up. It's big data, so you need proper tools to analyze this. But as a presentation layer, doing these things, that works really well, and it's not that difficult to do. That would be my key message here. Like, it looks complicated, it's not easy, But there is a lot of help out there from our studio, also a little bit from us. And the future is looking really good for apps, I think, that use R. So I hope you like R and you start using it a lot. This is really cool. Yeah? Okay. Yes, sir?
I have a question. Where do you use this application? I mean, you show it to the clients or just for your team or?
Excellent question. So where do we use R? How do we roll this out? So we use it indeed in two places. We use it internally to make other people understand our data. So not everybody is a data scientist. And it helps them, but it's also pushed to our clients. So we use Shiny Server on-premise. It's a private hosting company because our data cannot be in the cloud like that. It has to be secure. It's very strict rules, so I cannot go to Azure and say, just put it there and I just forget about the Patriot Act, which happens in America. That's not going to happen on this data, so that's much more difficult. But Shiny Server is a product by our studio, makes it extremely easy to host it. If you put it in a Docker container, if you set it up once right, you can roll it out very easily to other clients, other things. If you can do Linux, then you're set. It's not difficult to do. So that's also a recommendation if you roll it out, including your testing, get your stuff into Docker containers and make it work. Any other questions?
Thank Herman again.